So we saw sampling distributions yesterday. Remember in our notes when we did our tables? Remember when we saw our parts yesterday? So that was a sampling distribution. Now we're going to do sampling distribution of a sample. We're going to do our charts here. So let's take a look at here. The probability distribution shown here describe a population of measurements that can assume the values 4, 5, 6, and 7. So I have 4 different numbers that I can choose from, each of which occurs with the same relative frequency. Okay, what does that mean? Same relative frequency. That means they have the same opportunity to happen. This is another way we say equally likely. So all of this have the same probability. There's 4 of them. So I'm going to say each of these probabilities is 0.25. One thing that we know from probability, if I add all of my probabilities, it has to equal to 1. If you add these probabilities, it does equal to 1. Okay. Now, for the first example we're going to work with, yeah, each of my examples is equally likely. On your homework, they're not all equally likely. They have different probabilities. We're going to work some of those in the lecture today. But like I said, for the first part, they are all equally likely. So here, what are the different values? What are all the different samples of N2 measurements that can be selected from this population? Okay, so what that means, N equals 2 measurements. So if you chose 2 numbers, right, you choose a number first. And again, I can either get a 4, 5, or 6, or 7. You choose a number, and then you choose another number. What are all my different samples? I'm going to say, well, I can get a 4 and a 4. Notice I've separated with a comma. I could throw it, I can choose a number, I choose a 4, and then I choose another 4. Let me separate this with a colon. I could get a 4 and a 5. Now, some of you might be wondering, why are you separating with a colon and not a comma? Because notice how my set has a comma in it. My answers have a comma in it, so I don't want to get confused. My commas are part of my answers. My colon, that little dot and comma, separating my possible answers. Okay, so I said I could get a 4 and a 4. I could get a 4 and a 5. I could get a 4 and a 6. I could get a 4 and a 7. Right? These are all my possible cases that I get a 4 to begin with. But what if I get a 5 and a 4? Right? What if I get a 5 instead of a 4 on my first try? So I could get a 5 and a 4. I could get a 5 and a 5. I could get a 5 and a 6. Or I could get a 5 and a 7. Right? Those are my possible cases if I get a 5 to begin with. But what if I get a 6 to begin with? Okay, so my pairs could be 6 and 4, 6 and 5, 6 and 6, or 6 and 7. Those are my 4 possible cases if I get a 6 to begin with. Lastly, what if I get a 7 on my first number? I get a 7 and a 4, get a 7 and a 5, a 7 and a 6, or a 7 and a 7. When I ask you for the samples of 2, what I asked you was, if you choose 2 numbers, remember the only numbers you can choose are 4, 5, 6, 7. So basically, if you choose 2 numbers, right, you're going to choose a number first and then a second number. What are the possible outcomes that you get? Now, calculate the mean of all different samples of N2 measurements that can be selected from this population. All right, to make it easy, I already made the example here. So you guys see my next chart? You guys see it? There's the next, I wrote on each of those the different possible samples that we can get. But now here it says calculate the mean. Okay, so let's take a look at the first sample. A 4 and a 4. What is the average of 4 and 4? Remember, when we do average, we add the numbers. So like I said, I'm just looking at the first case. we add the numbers and then we divide it by how many numbers we added. So I'm going to go 4 plus 4 divided by 2. Remember, I'm going to add the numbers, so 4 plus 4, and divide it by 2 because there are two numbers. So 4 plus 4 divided by 2 is 4. Now, in the next case, 4 and a 5. Well, I'm going to add the two numbers, 4 plus 5, and then divide it by 2, because again, I'm adding two numbers, right? I'm getting the average. We know how to do average. So 4 plus 5 divided by 2 gives me 4.5. The average of 4 and 6, right? 4 plus 6 divided by 2, I'm going to say the average is 5. Now, the average of 4 and 7 is 5.5. The average of 5 and 4 is 4.5. The average of 5 and 5 is 5. I'm going to do the average of each of these just fast. Remember, the average for each of these cases, I'm adding the numbers and dividing it by 2. The average of 6 and 5 is 5.5. The average of 6 and 6 is 6. The average of 6 and 7 is 6.5. The average of 7 and 4 is 5.5. The average of 7 and 5 is 6. The average of 7 and 6 is 6.5. And the average of 7 and 7 is 7. Okay, I did my average of all my tables. Now it says complete the sampling distribution table. Type the X bar. That's a new symbol that we're seeing. We read this as X bar. Now, what does that mean? That is the how we write average. That's a symbol for average. I didn't quite mention it, but I had it over here. Okay, that's the symbol for average. Okay, so complete the sampling distribution table. Type the average values in ascending order. Okay, ascending order, that means they're going up. Okay, so I already found all my averages. What's the smallest average that we found? Is 4, right? Is that the smallest that we found? Yes. Okay, after 4, we found 4.5. And then we found 5. Did we find a 5.5? Yes, I see it right there. Okay. Did we find a 6? Yes. Then we found a 6.5. Then we found a 7. Did we find anything bigger than 7? No. Okay. So I got my tables. Now, what's the probability of each of these happening? Well, how many 4s did we find? Let me find the first one. What's the probability of 4? How many 4s are there? It's only one of them, right? How many are there total? Count the squares up there. How many numbers are there total? 16 of them. Okay, so my probability is 1 out of 16. When I type this, is gonna, if this was a homework and I'm filling up a table and I write 1-16, probably on the instructions, I will tell you to write it as a decimal. And I will even tell you to round it. I might even tell you round it to 2 decimal places, round it to 3 decimal places, round it to 4 decimal places. Now, if I don't say to round, don't round it. But I still want it as a decimal. Just don't round. In this case, I'm not gonna round. So I'm gonna say my answer is 0.0625. Okay. What's the probability of 4.5? I see 4.5 twice. Okay. So it's 2 out of 16. I'm gonna grab my calculator. I'm gonna go 2 divided by 16, and it gives me 0.125. Okay, what's the probability that I get a 5? Well, how many 5s are there? I see 1, 2, 3. Okay, so there's 3 out of 16. I grab my calculator. 3 divided by 16, and it gives me 0.1875. Again, if this is a homework, I'm expecting the decimal value. Now 5.5, I see 1 right there, 2, 3, 4. Okay, there's 4 out of 16. Now 4 divided by 16 is 0.25. Now some people might be lazy and they'll be like, haha, I'm gonna trick Mr. Leon. So 1 out of 16. Some of you might be looking for patterns. Okay, 1 out of 16, 2 out of 16, 3 out of 16, 4 out of 16. So this must be 5 out of 16. Well, let's see if it's true. How many 6s are there? I see this one, this one, this one. Oh, I guess it was not 5 out of 16, right? So I do encourage you to always do count them anyways. 3 out of 16. Now 3 out of 16, 3 divided by 16 is 0.1875. Now 6.5, how many 6.5s do we see out there? I see 2 of them. And 2 divided by 16 is 0.125. And then 7, right? How many 7s do we see? Let me erase this. Is 1. I only see 1 7 out of 16 total. So 1 divided by 16, it gives me 0.0625. Now, if you add all the probabilities, this plus this plus this plus this plus this plus this, if you add all the probabilities, I can assure you it does equal to 1. We have a rule that when we add all the probabilities possible, it has to equal to 1. Okay, good. Now consider the population described by the probability distribution above. The random variable is observed twice with independent observation. Use probability given. Fill the table below. Okay, so I'm just gonna choose the probability that was given above at the very beginning. And what I mean with that is this table, okay? The probability at the beginning. Now I'm gonna go here. Probability of 4 and then choosing a 4. Now using the table, probability of 4 was 0.25. And then obviously probability of 4 again was 0.25. What I'm going to do, I'm going to multiply those two probabilities. What's 0.25 times 0.25? Like I said, I'm just using the probability given at the beginning. Well, this gives me 0.0625. Okay. Now, 4 and 5. What's the probability you get a 4 and a 5? Well, probability of 4 to begin with, according to the table, was 0.25. The probability that I get a 5 was 0.25. Now 0.25 times 0.25 gives me 0.0625. Let me erase this. We take a look at the next group. The probability of getting a 4, right, according to the table to begin with, probability of getting a 4 was 0.25. The probability of getting a 6 was 0.25. Now 0.25 times 0.25 is 0.0625. Now some of you might be wondering, like, I keep on getting the same thing. And I'm going to say, yeah, because remember how the probability of each number to begin with was equally likely? So can I just say on all of this, I get 0.0625? Yes. So let me just multiply all of this. 0.0625, 0.625, 0.0625, 0.0625, 0.0625, 0.0625, 0.0625, and 0.0625. Okay. It is boring because they had the same probability to land with. All right, they were all equally likely. Now, your homework, I'm not going to make it this boring. I'm going to give each of these different probabilities. Okay, but let's take a look at here. I'm just using the probabilities. Now, using the probability given, fill the table below, complete the sampling distribution table, type the X bar, X crossbar. Remember, that's the average values in ascending order. So I already have the averages are going to be 4, 4.5, 5, 5.5, 6, 6.5, and 7. Okay, so I'm looking at which of these values will give me an average of 4? Well, only if I get a 4 and a 4, right? Because of this next average, it's just 4.5, right? So average of 4 and 5 is not 4. Okay. So this is the only case. Okay, so in this case, I'm going to say my probability of getting an average of 4 is 0.0625. Okay, what's the average that I get at 4.5? Well, here or here, right? I get a 4 and a 5 or a 5 and a 4. Let me add them all up. 0.625 plus 0.0625, right? I'm going to add them both. And it gives me, right, I'm going to use my calculator, 0.0625 plus 0.0625. And according to my calculator, I get 0.125. Good. Now, what's the average? How can I get a 5? My average 5. Well, if I get a 4 and a 6, right, that gives me 5. If I get a 5 and a 5, or if I get a 6 and a 4, right? Okay, so I'm going to add all those probabilities. Again, I was looking at which of these numbers will give me average of 5? There were 3 cases. So I'm going to add this up, 0.0625 plus 0.0625 plus 0.0625. According to my calculator, I get 0.1875. Nice. Okay. What's the chance that I get a 5.5? My average of 5.5. Well, if I get here, right? 4 and a 7, 5 and a 6, 7 and a 4. Is there anything else? 5.5, basically, I need to add up to 11, right? How about a 6 and a 5? Okay, so let me add all those. 0.0625 plus 0.0625 plus 0.0625 plus 0.0625, and it gives me 0.25. Nice. Now let's take a look at an average of 6. Okay, so in order for two values to have an average of 6, they must add up to 12, right? So I could get, let's see, a 5 and a 7, I could get a 6 and a 6, or I could get a 7 and a 5. Okay, add all this, and I'm gonna say 0.1875. Interesting. Now, my average is 6.5. In order for two numbers to have an average of 6.5, they need to add up to 13, right? Because 13 divided by 2 is 6.5. All right, so I'm looking at which numbers add up to 13. And that's going to give me a 6 and a 7, or a 7 and a 6. So I'm going to go 0.0625 plus 0.0625, and that gives me 0.125. And lastly, in order for two numbers to have an average of 7, they must add up to 14. The only case when my numbers add up to 14 is here. So I'm just going to say my probability is 0.0625. Couple of things I want us to see before I continue here. When the numbers could be shown, right, we could look at the cases. We completed a table with the means. What were the means? We found the probability of each of those. Then, give it using the probability only, right? I didn't list the cases, looking at the probability only, which is how you guys are mainly going to be looking at your work. I can complete this table, and based on that table, I'm going to complete this probability table. I want us to be able to look. I want you to pay attention to these two tables. You see my two arrows? I want you to take a look at those two tables. Do you see a difference between them and the probability wise? If you notice that same table, I can figure it out using only the probabilities. Wow, that was really nice. Now that I know my probabilities, let's see, based on the table given, what is the expected value? And what is the expected value of each probability? Okay, so here, the expected value, I could choose a 4, 5, 6, and 7, right? The way I'm going to find my expected value, I'm going to go 4 times 0.25 plus 5 times 0.25 plus 6 times 0.25 plus 7 times 0.25. If you notice, these are the numbers that were initially given, and I multiplied these two pairs, right? Well, these pairs, right? 4 times 0.25, each x with its corresponding probability. And then I add them all up. And that's how I'm going to figure out my expected values. My expected value, my E of x, is 5.5. Now, I also see here, what's the probability of that? What's the expected value of the average? So then I'm looking at, let me do this in green. I'm looking at this paired with this paired with this, with this. So what I mean with that, the expected value of the probability is 4 times 0.0625 plus 4.5 times 0.125 plus 5 times 0.1875. For space purpose, let me go here. Plus 5.5 times 0.25 plus 6 times 0.1875 plus 6.5 times 0.125 plus 7 times 0.0625. Use a calculator if necessary. What I'm going to do, I'm going to do each of my multiplications, and then I'm just going to add all the results, and it gives me 5.5. The expected value of x and the expected value of the average ended being the same? Huh, that's interesting. Remember, this was the expected value of x, and then we have the expected value of the average. That's interesting. Okay, let's take a look. So now we have this right here. This is my average, right? I use this table for here, and then this table for this. So you guys are wondering, where did I get my results? There you go. Okay, now consider the following population described by the probability distribution shown below. So we can choose two numbers. There's numbers we can choose. I could choose 2, 3, 4, 5. Now, they're not going to be equally likely. Right? They're not going to be equally likely. You notice the probability, it is different. Because when it was equally likely, it was a little not too fun. Right? There was a table that repeated itself. It was a little boring. And I said, in order for your homework to be not that boring, I'm going to make it not equally likely. So here, complete the sampling distribution table. What's the probability I get a 2 and a 2? So the way I'm going to look at this, the probability that I get a 2 is 0.3. The probability I get a second 2 is 0.3. So the probability I get a 2 and a 2, let me multiply those out. 0.3 times 0.3 is going to give me 0.09. Not bad. So what's the probability I get a 2 and a 3? So I'm going to look. Probability that I get a 2, according to my table, is 0.3. The probability I get a 3, according to my table, is 0.2. Multiply those out. 0.3 times 0.2 is going to give me 0.06. Cool. Now, what's the probability I get a 2 and a 4? Let's take a look. I see, what's the probability I get a 2? 0.3. What's the probability that I get a 4? 0.3. Multiply those out and I get 0.09. Following this same order, the same idea, I'm going to complete the table. So I probably get a 2.5 is 0.06. This 0.06. I probably get a 3.3 is 0.04. The probability to get a 3.4 is 0.06. The probability to get a 3 and then a 5 is 0.04. Probability to get a 4 and then a 2 is 0.09. Probability to get a 4 and then a 3 is 0.06. The probability to get a 4 and a 4 is 0.09. The probability to get a 4 and then a 5 is 0.06, 0.06, 0.04, 0.06, and lastly 0.04. Okay, so I completed my table. Now complete the sampling distribution table. Type the medians in ascending order, and then they are. The averages can be either 2, 2.5, 3, 3.5, 4, 4.5, and 5. Okay. So my average is 4. In order for two numbers to give me an average of 4, average of 2, the average is 2. So in order for two numbers to give me an average of 2, they must add up to 4, right? Because 4 divided by 2 is 2. So I'm looking at what are the values that my numbers add up to 4. And this is the only case, a 2 and a 2. So probability that I get an average of 2 is 0.09. Okay. In order for two numbers to give me a 2.5 average, that means that my numbers must add up to 5, right? Because 5 divided by the two numbers is 2.5. So I'm looking at my numbers adding up to 5. That's either I get a 2 and a 3 or a 3 and a 2. Okay. Add all those probabilities. So 0.06 plus 0.06 gives me 0.12. Okay, so now in order for my numbers to give me an average of 3, right? In order for two numbers to give me an average of 3, they must add up to 6. Because 2 plus 4 is 6, 3 plus 3 is 6, and 4 plus 2 is 6. I'm looking at them adding to 6. Because in order for them to have an average of 3, they must add up to 6. Okay, add those probabilities. So 0.09 plus 0.04 plus 0.09 is going to give me 0.22. Okay, so now my average is 3.5. Oh, why do my numbers have to add up then? In order for two numbers to give me an average of 3.5, they must add up to 7, right? Because 7 divided by 2 is 3.5. Okay, so in order for them to add up to 7, it's either a 2 and a 5, 3 and a 4. I'm looking at the pairs of numbers that add up to 7. Oh, here's another one, the 4 and the 3. Did I miss any others? Nope. Okay. So let me add all these things up. 0.06 plus 0.06 plus 0.06 plus 0.06. And that gives me 0.24. Okay. Now my average is 4. In order for two numbers to give me an average of 4, they must add up to 8. Okay, so let me see which numbers add up to 8. A 3 and a 5, a 4 and a 4, and a 5 with a 3. Okay, so let me add all those up. 0.04 plus 0.09 plus 0.04. That gives me 0.17. Okay, so now I'm looking at my average 4.5. In order for two numbers to give me an average of 4.5, they must add up to 9. Okay, so that happens when I get a 4 and a 5 or a 5 and a 4. Now 0.6 plus 0.6 gives me 0.12. And lastly, in order for my two numbers to give me an average of 10 or 5, they must add up to 10, and that only happens with a 5 and a 5. And my probability here is 0.04. So I'm able to complete my whole list. My question to end this, what is the probability that the median is 4 or higher? What I'm asking is, see here, my probability is 4 or higher. Okay, we'll add those probabilities. 0.17 plus 0.12 plus 0.04. And my answer here will be 0.33. Oh, that was easy.